Okay, so what if you could design, finance, and run an entire factory before a single brick is ever laid? It sounds like something out of a simulation game, right? Well, that's exactly what the Teknik Industri department at STT Wastukancana-Purwakarta is doing with their incredible Capstone design program. They're building a whole garment factory from the ground up, digitally. Let's break down how they pull this off. You know, this is the classic challenge for any engineering program, right? How do you bridge that massive gap between classroom theory and real-world consequences? I mean, how do you give students the experience of making these huge, high-stakes decisions on a multi-million-dollar project without the multi-million-dollar risk? Well, their answer is a project they call Capstone Design. And let me tell you, this is not your typical final exam. It's the super immersive 2-semester journey where industrial engineering students have to pull together everything they've learned to tackle one massive challenge: designing a profitable garment factory from scratch. So the whole journey kicks off in semester 6, and here the students take on the role of the architect. Their first job isn't to build anything physical, but to create the master blueprint and prove, with some pretty intense analysis, that this factory should even exist at all. And this is a really methodical process. They start with market analysis. The first question you should always ask: is anyone actually going to buy these shirts and pants? From there, they dive into the technical details: the best location, the right machines, the most efficient layout. But most importantly, they build a complete economic model to answer the million-dollar question: is this whole thing going to be profitable? The result of all this work is a massive feasibility report that will literally make or break the entire project. And listen, the students aren't just guessing here. As you can see from these metrics, they're using the exact same financial tools a real-world board of directors would use. They're calculating net present value for long-term profitability, internal rate of return to check the growth potential, and the payback period to see just how fast they get their money back. This isn't just theory. It all leads to a very real, data-driven go, no-go decision, just like in a corporate boardroom. All right, so assuming their analysis gets the green light, the students' roles completely flip. In this second phase, during semester 7, they hang up their architect hats and they become the builders. So, the feasibility study passed, the numbers work, the plan is solid. Now it's time to bring that blueprint to life. It's time to construct the entire factory, not with steel and concrete, but with some seriously powerful software. And to do this, they have 2 key pieces of software in their digital toolkit. First up is Odoo, which is an ERP system. Think of it as the factory's digital nervous system. It manages absolutely everything, from getting materials from suppliers to shipping out orders to customers. Second is Vensum, which is basically their what-if machine. It's a simulation tool they use to stress test the factory. What if material costs go up? What if sales suddenly drop? They can test it all. And this is where things get incredibly hands-on. I mean, they don't just use the software on their own computer. They build a physical, functioning mini supply chain right there in the lab. It's so cool. One PC acts as a supplier, sending an order for fabric. The student's own laptop is the factory, processing that order in Odoo. And then another PC acts as a customer, ordering the finished clothes. It's a complete end-to-end live simulation. So after 2 whole semesters playing both the architect and the builder, what's the final result? What comes out on the other side? Well, the program forges a fundamentally different kind of engineer. You see, this whole program is meticulously designed to ensure students master the entire field. In fact, it intentionally covers all 12 core areas from the official industrial engineering body of knowledge. That's basically the complete playbook for the profession. So this isn't random. It's a super comprehensive and systematic approach. And you can see that amazing breadth right here. On one side, you've got all those high-level strategic skills from their architect phase, things like economic analysis and system design. Then, on the other side, you have the hands-on, roll-up-your-sleeves technical skills from the builder phase, like actually implementing ERP systems and managing a supply chain. They truly get to experience the full life cycle. This chart here gives us a really great snapshot of how the curriculum is balanced. You can see how significant chunks of time are dedicated to both that strategic front-end work, like economic design, and the technical back-end implementation, with IT and supply chain making up a huge piece of the puzzle. So, what does this all add up to? I mean, why is this particular approach to engineering education so important? What's the big takeaway here? Well, it matters because it directly delivers on the university's vision. STT Wastukancana's goal is to become a top-tier industrial engineering program by mastering technology. This capstone project isn't just a class, it is the living, breathing embodiment of that vision. It proves they can produce graduates who can build and manage the integrated, tech-driven systems of the future. And really, the ultimate outcome is a complete transformation. A student walks in with theoretical knowledge and walks out as an industry-ready professional with real applied skills. Instead of just solving problems in a textbook, they're making actual investment decisions and building functioning digital systems. They graduate not just with a degree, but with a portfolio that proves they can do the job from day one. And that kind of leaves us with one final big thought. By combining high-stakes strategic decision-making with hands-on technical implementation all in one seamless project, this program creates graduates who have already run a factory before their first day on the job. Which really makes you wonder, is this intensive, integrated, simulation-based approach the future of engineering education?